Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for this week's episode. I've got a couple vehicles, well, actually three, but we're going to go through two of them kind of at the same time with case studies relating to vehicle communications and network failures. You might be saying, oh, wow, you're doing this again. And I know I've done a lot of communication case studies and episodes in the past, but I keep coming back to these things because it is my number one call, the number one thing that I get called on for diagnostic work. Okay, so when I'm getting called in to look at a vehicle at a shop for an issue, it's very common to be network communication related. I also run into this a lot when attempting to program a control module for a shop ends up leading to a network communication fault that they want us to work through. So anyways, I see people out in the field get hung up with this a lot. And so I'm going to offer my perspective and my insight on a couple of vehicles. They were interesting enough in their own right, but at the same time, just want to point out some tips, tricks, and things to think about as you're going through or diving into a network communication problem, because it can be tricky, right? For a reason, it can be complex and it can appear to be overwhelming, but I think we can break it down and, like we talked about last week, develop a process that's going to get us through and get to the solution. If I can figure these things out, I'm sure any of you can as well. So let's jump into this. The first two vehicles, and we're going to kind of do these at the same time, and I'll explain why, but it's a 2014 Dodge Grand Caravan and a 2015 Jeep Wrangler. All right, so they're both Mopar vehicles, and that's kind of why I'm grouping these together, and they ended up having a very similar but not exactly the same problem. And again, the reason I wanted to point this out is part of the process is going to get us to the correct problem, get there efficiently, but also accurately. And there's a number of things here that can slip you up and send you in the wrong direction, make the bad call. So how do we avoid that? But I'm going to start out with the Caravan. And reason being is, in the real world timeline, this was the first vehicle that I worked on of these two. Now, oddly enough, you'll see the problem is almost exactly the same. But the two vehicles were actually at the same shop within a couple weeks of each other. So I don't know how this stuff happens, but it happens. And again, very, very similar problem, although not the same. But I worked on the Caravan first, and shop called me. They recognized, hey, we have a communications issue. We made our checks that we're capable of or that we're willing to do, and we weren't able to find anything. Can you just come in, figure this out, let us know what's wrong with it so we can proceed with the repair. All right, cool. So I come in, take a look at this Caravan and verify that I do have communication issues with several modules on the vehicle. Now, right at the start of the diagnosis, when you're dealing with a communications issue, once you've verified that, yes, I can't talk to a module or several modules like I have in this scenario, you're sure it's not like a scan tool thing or something like that there actually is a physical problem on the car. The first thing you should be doing here is understanding how the network is constructed. And that's one of the points that I'll probably make several times throughout this episode. I know I've said it in the past. It's been in classes if you've gone to classes for network diagnostics, but it is really, really important, and it's often overlooked. I mean, you can take this outside of network stuff too, and it's true, but For networks specifically, you really do need to have a diagram or a topology laid out in front of you. And I prefer the OE diagram whenever possible. I will use redrawns depending on the scenario, but I really do like to see the factory setup for this, the network on the vehicle. And in this case, there's multiple networks on this vehicle. And heck, that's most vehicles nowadays, is you're going to have multiple networks and multiple CAN networks, right? There's 2 different CAN networks on this Caravan. There's a CAN C, which is going to have our powertrain control, our ABS, our wind module, and then the interior CAN, which is going to have stuff like power sliding door modules and seat modules and things like that. And it's divided up into 2 sections, the TIPM being the gateway for these. And that's another important part, right? That I'm using a diagnostic CAN to link my scan tool to the TIPM, which then links me to the other networks on the vehicles. And that's important to know. Even just plugging my scan tool in is what's actually happening, is that I've got to reach out on a dedicated diagnostic network to the TIPM, and then it's going to feed me information about the other networks. I'm not hardwired into them at the DLC. Okay. Important piece of information to know, but you see that if you pull up the diagram and see how it's constructed, right? And again, depending on how the network is constructed, this will show you, okay, what modules are located where, right? And if you have a scenario like I do right now where I can't talk to multiple modules on the vehicle, I want to know what network do they live on, what other modules are on that network, and if I'm going to proceed with testing or try to come up with a testing process for this, how do I access that network, right? Can I go right to the DLC, or am I going to have to go to, in this case, a gateway module, a TIPM, in order to actually do any testing on the physical network, right? Because a lot of the time, if we want to figure out what's going on with a network, we have to be physically connected to it to see what's going on with it, right? Is this thing being pulled to ground? Is there garbage messages being put out? Is it shorted of power? What's happening with the network? And, what's our next step after that? But I've got to get connected to it. Again, having a diagram in front of you will help you decide where to do that, or if you need to do that. If it's a GM, I'll go right to the DLC in most cases. And if it's a Chrysler, I'm probably going to be going to the TIPM in most cases. Of course, there's examples where that's not true on both brands, which goes back to my point, is you got to look this up almost every single time. I mean, maybe if you're working on the exact same year, make, and model over and over and over again, maybe that is something where you don't have to pull out the diagram all the time. But I'll give you an example on the GM later where even though I do a ton of these things, I had to look at the diagram to understand what I was dealing with. And it almost becomes, on a lot of vehicles, where you have to take it on a case-by-case basis and look up each vehicle, because there are so many different options, especially on something like a minivan or, a SUV or a truck. There's so many different options that you could have different module configurations depending on what that car came equipped with. And it's your job as the technician to figure out, okay, what modules actually exist on this vehicle, right? If I'm going through with my aftermarket scan tool, which won't necessarily tell me which modules are equipped and which ones aren't. If you have Y-Tech, that makes things a little easier on these. But if I'm using an aftermarket scan tool, which a lot of us are, it's not going to say, hey, this car doesn't have a power sliding door module, or this car doesn't have a tire pressure control module. It's just going to gray it out on the topology screen of the scan tool, if it has one. And you're going to say, oh, there's no comm to it. Well, maybe it doesn't even exist on the vehicle, right? That's part of this process too. And the diagram, a wiring diagram, is not necessarily going to tell you that. If you're working on a GM, you can use the RPO codes that are embedded within the diagram. But it is something that you're going to have to figure out depending on what you're working on, so you're not chasing something that doesn't even exist on the car. Now, one other note that I can give you here on the Chrysler stuff, and I don't know exactly what year that they started this. I know we've got some Chrysler, Dodge technicians out there. They could probably, give us the era where Chrysler started doing this, but you can access it in aftermarket service information as well. I was using Identifix here. Is when you're searching for the CAN network, you can look at the actual wiring diagram to see, pin terminals and wire colors and the modules on the network. But you can also search CAN layout, and what you get is a 3D picture of the vehicle with the harnesses that contain the network wiring in a 3D space. So these harnesses are going to be colored, and it's going to show you exactly where the CAN network runs throughout the vehicle based on the network that you want to see, right? So you can look up a CAN layout for CAN C, you can look up a CAN layout for the interior CAN, and there'll be different pictures where it's almost like an X-ray view through the vehicle, and you see where all the harnesses run, and it points out all the different modules, where they're at on the vehicle. Now, this can be tremendously helpful if you're looking for a break in the network, or even if you're looking for connector locations, module locations. It's all in this one 3D picture. Really, really helpful. So if you're doing stuff with Dodge, Jeep, Chrysler, Mopar stuff, and you're doing network things, and you're doing a network diagnostic, look up the CAN layout picture along with the wiring diagram. It's really, really helpful here. So back to this vehicle. When I hook up to when I hook up to it with a scan tool, I can't talk to anything on the CAN C network. So for reference, that is our PCM, our ABS module, tire pressure control module, airbag module, our wind module, and a couple other optional modules like steering effort control and pedestrian protection module. Those are ones where I'd have to find out if those things even exist on this vehicle, but nothing on that network will talk to my scan tool. Again, I have to go through the TIPM to do it, but I can talk to the TIPM. I can get codes out of there, which are all communication codes, and I can talk to everything on the interior CAN, which is a whole bunch more modules, like power sliding doors and seat modules and cluster. And at this point, I don't really care what's on the interior CAN because I can talk to everything on it. I can't talk to my CAN C, but I can talk to my TIPM. Okay, now where do I go on this one? Again, because the TIPM's the gateway, I have to physically access that CAN network. And where I usually prefer to do this is right at the connector of the TIPM. Reason being is I know where it is. It's easy to access. It's easy to pull up. And I've already pulled up a diagram, so I know my wire colors and my pin numbers, and I can just back probe right into the back of the TIPM. Takes me a few seconds, and I'm tied into the actual CAN C, the one that I'm assuming that I'm going to have an issue with. So that's where I decided to tie into this vehicle. So once I do that, I'm using my U-scope, and I just want to see what's happening voltage-wise on the network. Is there what appears to me as normal CAN messages, or does it look corrupt? Is it way off in one direction or another? You're right. Is it pulled all the way to ground, shorted up to power, or again, just garbage messages? And what's a garbage message? Well, that's one of those things where you have to see a lot of functioning CAN networks to be able to say that, yes, this does not look normal. And I guess it's hard for me to describe audio only, but so when I connect to this with the U-scope, I see that the CAN C bus is actually shorted all the way to power. And that's on both sides of this network. Now you can still see what appears to be a slight bit of network activity. And what I mean by that is like little pulsations in there, but the baseline for the network is up at battery voltage, which it's not supposed to be. CAN C bus, we should have a 2.5 as our resting voltage, and then it goes up and down depending on the side of the network. But 12 volts or battery voltage on that, on both those wires is wrong. It's dead wrong. You see that. There's no question. You don't have to question whether it's garbage message or not. Nothing can talk when it's shorted up to 12 volts. Okay. So how do we proceed with this? We've obviously found an issue. This is why nothing communicates on the vehicle. Now, this is a large amount of wiring, and the size of the network is pretty large in this minivan. We have a lot of different possibilities. And it's at this point, I want to ask myself, what are the possibilities of why this is short of 12 volts? What could be happening, right? Of course, we could have a wire that's shorted to the CAN network, pulling it up to 12 volts. And does it have to be shorted to both wires at the same time? Or would it feed that volts across the terminating resistor? I'm not really sure on that. It's a possibility, though, is we could have some type of physical short, the twisted wire pair pinched up against a 12-volt circuit. That's a possibility. We could have an aftermarket device tied into the CAN network somewhere that could be doing this. Or we could have one of the actual control modules, the factory control modules on the vehicle that is shorting 12 volts to this network. And that's, in my mind, the most likely scenario is a control module that's shorting voltage to it. And when I say aftermarket device, it could definitely be considered a control module. I'm thinking, remote start device or something like that. But anyways, those are the possibilities. How am I going to narrow this down? How am I going to track it down to what it actually is? What is the process here? And this, again, comes back to understanding how the network is set up, right? When we looked at our diagram or looking at our diagram for the network, we have to make a decision. Okay, how do I break this down into smaller pieces? Where do I go? Where do I start testing? What do I do with this? And if you don't have a picture of the network in front of you, you don't have an understanding how everything's connected, this is where the diagnostic for a lot of people falls apart. One of the best examples I can give here is the network set up like a traditional bus style network like it is in this Chrysler, or is it set up to be daisy chained like a GM style CAN network, meaning that the network goes in one side of the module and out to the other. And if you unplug that module, you've effectively separated that network. And in a GM, you have an open anywhere in that CAN network, and it's going to affect the entire network. Whereas on a bus style, and if you're not sure what a bus style is, imagine in your head one point in the middle of the screen, and you have 4 wires going into that one point, and you have a module at each end of those wires. So you have 4 modules, they all meet in the middle, right? If you had a wire break between the module on the right and the center point, the other 3 could still communicate. And that's your bus style setup, right? Whereas a daisy chain, any break, any unplugged module is going to cause an issue, not only for that module, but for everything else. And when I say that, I mean the overall terminating resistance of the CAN network will be affected for everything if you have a break in that GM style. Now, that doesn't mean that you won't be able to talk to everything on the network, but it brings up the point, if I'm going to use the terminating resistors, I want to know where they're located, but also how the network's set up, because quite honestly, terminating resistance in a bus style system like this Chrysler means a lot less to me. I mean, if I measure it and it measures 60 ohms, I can say, okay, well, those 2 modules are plugged in and connected, and that's great, but what about everything else? Whereas a GM, it's a different story. And the point of this wasn't go into the differences between the two, but to illustrate the fact that you have to know that there are differences between the two. And again, that's where looking at the diagram will help. I was working on something a while back that actually had a daisy chain set up, and it wasn't a GM. And I was a little surprised by it because I'm so used to seeing it almost exclusively used on GM, and it was on a different brand. So, and GM could come up with a bus style. I'm sure they've used it in the past. I mean, they do on their lower speed networks where you have to change your strategy. It's not going to stick all to the same brand. And again, I'm going to sound like a broken record. I get it, but you got to understand how these are set up on each individual vehicle before you proceed. So anyways, I have a shorted 2-power bus. How do I proceed with this? I can't show you the diagram, but what I like to do when I'm looking at the factory diagram, and this is one of the points that I wanted to make, is if you're going to go into a network diag, especially one where the whole network's down, it is in your best interest, in my opinion, to use the factory diagram as often as possible. There's a number of reasons for this, but one of the big ones here is I have noticed the redrawn diagrams that you can find in, anything, Identifix, Mitchell, ALLDATA, they don't include inline connector numbers, right? So if there's two modules and there's a connector that's in between them in a different part of the vehicle, those will not necessarily be on the redrawn diagram, whereas you will find them on the factory diagram, or at least hopefully. I haven't run into too many scenarios where they don't, but the factory diagram is going to include those connectors. Why is this important? We've talked about this before. I like to separate the network down into smaller sections to try to narrow down where the problem is coming from, right? And again, we have a short to power. So I want to know, where is that short to power coming from, right? It's coming into the network somewhere. I'm suspecting maybe it's a module. How do I narrow it down? How do I figure out where it's coming from? I'm going to split that network up. So now I can look at my diagram and try to figure out where's the best place to separate this network out, right? I don't want to start unplugging modules right now because there's a lot. I guess there's only 8 potential modules, but again, getting to 8 different control modules on a vehicle can be more difficult than it sounds. Sometimes accessing these things involves removing carpet, removing panels, other components just to get to them, to unplug them. In my opinion, the easier way to do this is to disconnect some connectors. So what I find here is called inline body connector 2, or also I301 if you're looking at the CAN layout, which again, this is where the CAN layout's awesome because it shows me exactly where it is on the vehicle in relationship to the CAN harness. But I also look on the actual wiring diagram and see I can separate this network basically in half at this point. It's in the left kick panel area. I find this connector, I disconnect it, and I found that my short to power is on a leg of the network that contains the ABS module, the tire pressure control module, and the TIPM and the PCM. Now, the PCM actually branches off on its own network, but it goes through the TIPM to do so, and I know that sounds a little confusing. But basically, we've got the PCM, the ABS module, the tire pressure module, and the TIPM itself, and everything else we've eliminated, right? That side of the CAN network actually scopes out okay. But now I've limited this down to 4 potential modules, which is half of what I had. So that's awesome. I'm going to go with that and see if I can figure out where it is from there. Now, I don't have any other inline connectors except for one near the ABS that I can disconnect here to limit it down any further. I did unplug that ABS connector because it was easy to get to, didn't change anything, still have power connected to that network. So the next one that I'm going to go to is the TIPM itself. And you want to be careful here because I'm going to unplug a connector from the TIPM that has my CAN lines. You want to be careful here because anything you unplug from the TIPM or a module like the TIPM, which is the fuse box and it's the power supply for most of the vehicle, you do risk cutting off power to the circuit, which is contributing to your problem. So what I mean by that is if the TIPM is putting out power onto one wire, it goes somewhere into the vehicle, and then somehow that wire is shorted to our network, or the module it feeds is shorted to our network, and we unplug that connector in hopes of just removing the CAN lines, we could be solving our problem and not realizing exactly why we're solving it. And you want to be careful even just disconnecting big connectors, because that could be true of those as well, right? You could have a power supply to a module in a big connector, and you're unplugging it just to separate the CAN network, right? I actually just did this on that 301. And what if you're, cutting off power to the module that's causing your problem? Now, in this case, I tested both sides of the connector and I still had shorted power on one side of the network. So I know it wasn't the connector, but we have to be aware of this, right? anytime you're disconnecting things with multiple circuits, you could be fixing or changing your problem by doing that. Another example, this is on Fords. They like to run the network through the same connector twice. So that's a CAN network. So they'll take two wires, go through the network, go to one side of the network for things, and then come back through that same connector to go to a different spot. And so if you unplug it, you're not paying close attention to the diagram. You've now separated the network in two spots. Okay. And same thing goes for this TIPM. I have to be careful when I unplug a connector on the TIPM because I could be taking power away from something else. So the one thing you can do here, if it's doable, is you can just de-pin the CAN lines. A lot of times that's not that hard. I have a lot of de-pinning tools for this reason. And I just want to take the CAN lines out of the TIPM, leave everything else connected. And my thought here is I can eliminate the TIPM here or prove out the TIPM, but I can also eliminate the powertrain control module because it comes in on a separate connector through the TIPM. The TIPM's just kind of like a pass through for that leg of the network. So I do that and I still have power on that network. And this is the side that goes out to the vehicle. I know this is a little tough without a diagram, but the only module that's left now is the tire pressure control module. Now, again, the CAN layout diagram is awesome because it shows me where this thing is. It's in the left rear wheel well. Now, it's not exactly clear where it is, but it's on the outside of the vehicle, right? What I mean by that is you can't access this thing from the interior, which in the diagram it kind of looks like you can, but it's on the outside and it's behind the wheel well, the plastic insert in the wheel well for the left rear wheel. You pull that back, you can access the tire pressure control module. I unplug that and the power finally goes away from that leg of the network that we're having problems on. And you could tell this module is full of corrosion. It's in a really bad spot. That's what needed to be replaced on this thing. I mean, of course, we can check powers and grounds, but you could see the physical corrosion on this module. I think they were going to have to do some work with the connector as well. But either way, we found the problem and I can connect it back, everything back up together. The vehicle starts and runs. And the only communication issue I have is with the tire pressure control module itself. All right. So my second vehicle was actually at the same shop and it was a 2015 Jeep Wrangler. Now I ended up at a very similar point with this Jeep. And I'm going to kind of breeze through the first part because it is exactly the same as the Caravan. Connect to it, can't talk to anything on the CAN-C network. Go to the CAN-C network at the back of the TIPM. IC power is shorted to the CAN-C network, almost in the same way as this Caravan. And they're 1 year apart, but they're completely different vehicles. Okay, yeah, they're still Chrysler vehicles. They still have the same setup, right? There's an interior CAN, a TIPM, CAN-C, very similar in that respect, but it's shorted to power just like this one was. And this was a couple weeks after, so it was definitely on my mind. And at this point, I had thought about the Caravan. So in between these two vehicles, I had thought about the Caravan and I said, how can I, do this more efficiently next time? I try to do that on anything that takes me a little bit of time. I'm like, okay, well, next time when I see this, what do I need to know? How do I move through this problem quicker? And I was thinking about what's actually happening to the network here when we have power B+ shorted to a network. It didn't occur to me in the moment on the Caravan, but after thinking about it later, I was like, well, wouldn't pulling fuses, specifically for the modules in question, but you could go more than just those if you needed to, but wouldn't pulling fuses be a more efficient way of finding the source rather than even separating the network, right? The separating the network in my mind is an efficient way to do it. But I took the time to de-pin a connector at the TIPM. And I mean, it took me a little bit of time to sort through all of that, even with a good plan in mind. And my idea here is, okay, well, next time I run into this, let's just start pulling some fuses, again, for the modules in question. And we might be able to eliminate this down with very little effort. right? If we pull the fuse to the module that's shorting power to the network, it shouldn't be able to short power to it anymore. Okay, yeah, and there's variables to this too, right? There could be multiple power feeds to one module. But I wanted to utilize this anyways just to see, would this get me to the solution quicker? And so fast forward to where I'm at this Jeep, I get to the exact same thing, shorted power on the CAN C. Okay, I'm going to try pulling some fuses this time and see what happens. And this doesn't work if you have a shorted ground. This doesn't work necessarily if you have garbage messages, and actually pulling power to a module can cause garbage messages. So the fuse pulling thing, I think I'm going to reserve for the times where I have power shorted to the network, but I wanted to try it here to see if it would work. I pulled a few fuses and I'm using the diagrams to figure out, okay, which modules are on the network and then which fuses power said modules. Right now, I think it was like the second or the third one I tried was the tire pressure control module. Why? Well, that was the problem on the last one, right? Maybe it's the same problem, even though it's a different vehicle. I mean, I just saw this and it's on the network in the same way. Let's pull this fuse and see what happens. So I pulled a fuse for the tire pressure control module on this Jeep. And when I do that, it goes back to normal. We have communication on the network. The power's not there anymore. Oh, okay. So this must be another tire pressure control module. Well, here's where we need to do a couple more things in order to verify that the module itself is what's shorting power to it, right? And here's where doing something like pulling fuses is a great step, but it's not your final step. There's more to it than that if you want to be exact. And I'm glad I did, because I could have just said, yeah, put a tire pressure control module in it and you'll be fine. That wasn't the case. So what I did was I put the fuse back in. I got power back on my bus. I go back to the tire pressure control module, which is on a cross member above the rear axle. I unplug it and it didn't change anything. And nothing was corroded back there. I still have power on that. Okay, is there something else on that power feed that I'm not aware of? Another module that's connected to that I didn't see in the diagram. Not that I could find. It seemed to be a pretty straight shot. So how else is power getting from the fuse that's feeding the tire pressure control module onto the high-speed bus on this Jeep? Well, I'm back to my original plan on the Caravan was I've got to divide and conquer because somehow power is getting from that circuit to my CAN network, and I don't know where, and it's quite a bit of wiring to get from the front of the TIPM to the back of the vehicle. But again, factory diagrams are going to show me where the connectors are. And there's an I-215 big connector that's going to be under the air box, kind of behind the radiator on the passenger side of the vehicle. And this has the power feed wire that goes back to the tire pressure module coming from the TIPM. It also has CAN wires in it, but this is the first place that I was going to try, mainly because I was already up at the TIPM. All I had to do was move an air box and unplug this thing, and I'm going to work my way back towards the tire pressure control module while I'm monitoring the CAN network to see when does the shorted power go away. Well, as soon as I unplug this connector, which is a large connector, I lose power. Now, again, like I was saying, be careful with big connectors because you can be altering other things at the same time. But I did happen to find my problem when I disconnected this big connector. It was full of water, moisture, and some corrosion that was causing a short internal in the connector. And as soon as I unplugged it, that short went away. So it was just a matter of cleaning/repairing this connector. Now, again, I thought it was so strange that I ran into almost the same problem on two cars, down to the same circuit providing power onto the CAN network, and yet it ended up being two different problems. But in my mind, it's about doing as much as you can. Once you get to what you believe is the cause of the problem, to prove it out in as many ways as you can. Right? Or almost try to, in some cases, I'll try to disprove myself. If I've said, okay, well, this is the failed component, I might try to say, okay, well, what else could it be? how could I prove that it is not this component that's causing the problem? What other tests can I do? And I'm glad I went back and actually unplugged the module in this case. It would have been really easy just to make the call on the tire pressure module. Say that's what you need. I just saw one of these. We just went through it. This same shop just went through it. They would have believed me. They would have plugged in that module and wouldn't have changed anything. It was the connector, right? But that's why I wanted to bring this stuff up and point it out, because I mean, there's so many pitfalls. There's so many variables. There's so many different things that we run into. The goal for me is to have some tests that prove something basic that can help me work through the complexity of these systems. All right, last vehicle here, 2015 Chevy Silverado with a 4.3 liter. That is important to note on this one. Shop called me for a fuel pump control module, which they had already replaced. And the reason that they replaced it was a U18A2, which is ECM lost communication to fuel pump driver control module, and a P2635, which is fuel pump flow performance. Both of these codes are in the ECM. Now, this truck does run and it builds fuel pressure. Maybe I should have said it that way. Builds fuel pressure and it runs. But we have engine light on and we have these codes in the ECM. After a fuel pump driver control module, which they tell me is plug and play on this model, it still sets these codes, but still runs and drives. So they didn't do any programming, but according to them, this is not a programmable fuel pump control module. I said, okay. And I was thinking the ones that I've normally done in Silverados, you do have to program. And so I was thinking, well, maybe that's what this is it just needs programming and they, missed something in service information, whatever. I said, I'll come check it out. And if it needs program, I'll sell them programming. If it needs a diag, I'll sell them a diag. Easy enough. So I get there and I confirm everything. These codes are in the ECM. The fuel pump does run. The engine does start. But I don't seem to have any communication with a fuel pump control module. Now, if you look at your scan tool on a lot of these Silverados, you'll see it listed as a chassis control module. It's an option in there. Well, I didn't have any communication with that either on my scan tool. Once again, broken record, you got to understand how the network's set up. This one was actually a new one for me. I don't see very many, if any, 4.3 liter Chevy Silverados. They're just not common where I am. Maybe they're not common at all, but this is the V6 version and I just don't see them a whole lot. But this one is, and looking at the diagram, this is really important to note. The fuel pump driver control module is not on the regular CAN network for this vehicle, right? So the whole 60 ohms through the DLC for the high-speed bus doesn't apply to this one at all, right? I don't have a communication with it. Normally, I'd be looking there first, not on this one. This one has its own, what they call a powertrain expansion bus, and it is a two-wire CAN bus, and it has 60 ohms to 120 ohm terminating resistors, but it is its own separate bus that is specifically between the ECM and the fuel pump driver module, which is back over the spare tire. But that's it. There's nothing else on that bus, including scan tool access. So you cannot actually connect to the fuel pump control module using your scan tool, even if everything is working correctly. Again, that's important to know because on the 5.3s, the fuel pump driver module is on that network. It's daisy chained in. It can be the cause of a lot of different problems, and you can talk to it with a scan tool, right? So I got to understand that before I proceed any. Otherwise, I'm going to be trying to talk to this thing with a scan tool, and it's never going to happen, even if everything's fixed correctly. So I kind of have to go off of the codes in the ECM saying, hey, I can't talk to this thing. All right, so new module. I'm going to access this first. I'm going to go there. What is my plan? Basically, I'm going to be checking the network that is between these two control modules and then also powers and grounds to my fuel pump control module. So I get back there. I U-scope into the network. I do have CAN communication there. I see it. It looks odd, and I'll come back to that. And I wasn't really jumping on anything quite yet because I definitely saw data packets. I definitely saw CAN activity. The voltages appeared to be about where they needed to be. Something was off about it though. And I'll come back to that, but I'm walking you through my thought process as I get into this. And I saw something doesn't look quite right about it. But next thing, I just want to verify powers and grounds. And specifically at this point, what I'm actually really thinking about is what's called a serial data wake up. So this module does receive what's called a serial data wake up, and you see this on a lot of GMs. And this is a wake up signal from the BCM. And people will miss this when they're doing their powers and grounds checks to GM control modules, because they'll say, oh, there's constant power, there's switched power. I check my ground. It's got everything I need. There's a data wake up that receives voltage, and that's going to actually tell the module to talk or to not talk on the CAN bus. And if that's not there, it won't talk even if all the other powers and grounds are there. Right. So that can be the cause of a no comm on a module. So I want to look for that. This does have it. I checked it. I've got powers. I've got ground. I've got serial data wake up. Everything appears to be good at this control module in the back. Okay. So what are our possibilities here? Did we get a bad control module? Does it need to be programmed? The answer to that is no. I looked in service information. No programming for this. This is a plug and play module. It should just work. And you could say it is working in the fact that it runs the fuel pump, which had it not done that, I may have gone harder after the module itself. But the fact that it ran the module, or I'm sorry, the fact that it ran the pump, I went back to my CAN network here. And again, this was just kind of a hunch. It was just something I saw. It looked noisy on the CAN signal is the best way I can describe it. Not like it was necessarily a garbage corrupted message on the bus. It just looked noisy. Like there was a lot going on between the data packets, right? The data packets would be a condensed chunk of voltage pulses that are coming out from a module. And then there should be some dead space in between those packets, right? It's like the modules are taking a breath before they say their next word. That really wasn't there. There was a consistent, what looked almost like a pulse width modulation voltage the whole time, anytime the key was on. And you could see a difference, and I'm actually going to put a picture of this up in the scan tool. You could see a difference in when there was an actual data packet and when there wasn't. But when there wasn't, there was about a volt pulse very repeatedly with even spacing. Right, the whole time. And this shouldn't be on a CAN network. This again looked like a pulse width modulation where there was no changes in the frequency. There was no breaks in it. It just kept on going. And it kept on going through the message as well. It didn't stop when one of the modules was talking. And this kept going and going, and it didn't stop as long as the key was on. And so I'm thinking I need to address this and see what's causing it. And luckily with this network, there's not too many options. It's either the module, the fuel pump driver module, or the engine control, or I don't know, maybe somebody tied something in aftermarket at some point, but it's coming from somewhere. And this almost has to be some type of module that's feeding this in. So the easy thing for me at this point was I swapped in the old fuel pump control module because I'm suspecting bad new part. So I put that in there and it's the exact same thing. No change at all, which to me seems very unlikely that two fuel pump modules are going to have that exact issue. It's possible, sure, but very, very unlikely. So I'm going to move somewhere else in my testing to try to prove out where this pulse width, I'll call it, is coming from on the network. Again, we're going to look at our diagram. How's this set up? There's a couple inline connectors, but X125 is going to be the easiest one for me to access. It's up on the left front strut tower. And this will allow me to separate this network into two pieces pretty easily. The ECM on one side and the fuel pump driver on the other. And so I do that, and it does disrupt the terminating voltage because there's a CAN resistor in both sides. Oh, I should mention that actually. I ohm checked the network while it was off back at the fuel pump module, and I had 60 ohms on that network, meaning that physically everything was plugged in and connected. And I did that before this, and I should note that because that led me to believe, okay, there's not like an open in the network, and I don't know why it would cause what I was seeing anyways, but everything was physically connected. until I go up to X125 and I break it in half. I go to X125 and I open it up. I break the network in half. Now I can test both sides. On the side of the fuel pump control module, I have my normal CAN data packets with no extra noise. On the side of the ECM, I have no CAN data packets, nothing that looks like actual communication, just a straight pulse width modulation of voltage. So it's coming from my ECM. So the ECM is about a foot from where I'm at X125. I can see the harness, don't see anything, obvious with the harness. I check powers and grounds at the PCM. I check my pin fit at the network wires for the expansion bus, although I'm not really that concerned about it because it all checked out okay. Everything checks out there. So the shop replaced the ECM, programmed it. We're good to go. No more communication codes. That's it. So that one was a little faster, but again, it illustrated the importance of understanding what you're working on, because I work on a lot of GMs. I work on a lot of GMs with fuel pump control module problems. When I was sitting in the driver's seat first looking at this thing, I had a completely different approach in my head as to what it changed to once I read up on exactly what I was working on. And that was the key. That's where I needed to be. I needed to be in that service information, understanding what was going on or how these vehicles were constructed before I could develop a test. And had I not done that, I really would have been in the dark for quite a while. And we talked about this last week with Rich Falco, having a process in place. But it is interesting that your process, the actual process that you take, is going to change quite a bit from vehicle to vehicle. This isn't like an assembly line where we're doing the exact same thing every car, every day, every week. It's so dynamic, and you have to be ready to pivot in order to get through these challenges. And I think the only way that we're going to be capable of doing that is having access to and being capable of taking in service information, right? Being able to interpret what's happening, how it's constructed, what components are involved, and then applying it to the specific vehicle that you're working on. That's the key to all of this, in my personal opinion. So those are my case studies for network communications. Hopefully that is helpful to you as you're out there trying to solve these problems. But I want to say thank you to everybody for listening. Thank you for the feedback. Really appreciate it. Let's all get out there, start fixing the world one car at a time.